Welcome back to the second lecture in hormones. So where we're going to pick up is we had talked about all the different hormones and the endocrine glands that they come from. And so we want to talk on, to just pick back up with that conversation. But where we're going to start is something you hear a lot of people using to enhance their performance. So an ergogenic aid or performance-enhancing drug of anabolic steroids that mimic the natural steroids we make. And how performance goes. And so you can read about that in your book, but initial studies showed no benefit in developing muscle mass. That's in contrast to real-world reports. Real-world reports. Anabolic steroids do tend to promote muscle mass, but it's not typically the way people think about it. People think if you take steroids that all of a sudden you'll just start bulking up on your own. But what they allow you to do is recover quicker. So typically when you train your muscles, it takes them about 48 hours to really to start having meaningful recovery, which is why you're sore for 2 days after you start a new exercise regimen. 2 days after that workout, you're still kind of sore. But what steroids allow to occur is allows for that recovery to happen quicker so that you can work out more often and build muscle mass. And so technically when people take steroids to see results, they're actually having to work harder than they would without them because their bodies can tolerate that. They're recovering quicker. And so it is attached to a lot of negative or associated with a lot of negative side effects. Some of those will revert to normal after you discontinue use of those steroids, and some will not. Depending on how much you're using and for how long you're using, some of the side effects from the excessive use may not actually go away. And so there is a lot of widespread use, and that's caused testing in all major league sporting, professional sporting across the globe, really. And actually, believe it or not, there are lots and lots of non-competitive athletes using steroids for their personal gains, for the way it makes them look, the way it makes them feel, but it's definitely there. And a lot of them actually do what's called stacking, which is where you take more than one steroid at a time, taking multiple different steroids because they all have slightly different effects, and you stack them or megadose them. And so it's something that is out there, and you should familiarize yourself with and realize there are lots of risks to them, and it increases a lot of long-term side effects that can last for years and years after the fact or show up years after the use, especially with extended amounts of time or just large amounts of those. And so it's not something I necessarily recommend, but they are out there, and so you're going to hear about those, and so you might as well educate yourself about them. So muscles also do act as an endocrine gland. They release some chemicals that can get picked up in the bloodstream and help signal other things, have other effects, or just local kind of hormones where they stay in that general area and produce that. So skeletal muscles produce what's called myokines. So these are very similar to hormones, and they happen during contractions. And these will stimulate glucose uptake and fatty acid oxidation. So when you contract your muscles, it's helping to draw glucose in so you can pull more energy and utilize that to make ATP through glucose and oxidizing fatty acids. Helps promote blood vessel growth, which can help with getting nutrients in and waste products out. And it also promotes, and this is how we know it's more of an endocrine because it goes more than just the muscle. It helps promote liver glucose production and triglyceride breakdown throughout the body. And so it's really this cool system where the muscles are helping themselves out. And so another thing they release is called interleukin 6 or IL-6. This is produced in other parts of the body as well, but it's anti-inflammatory and pro-inflammatory. So it's helping you to have inflammation in areas that need it, bring things there to help them recover, and then also keep inflammation away from areas that don't need it. And so this can be really helpful after exercise. And so regular exercise actually over time, because of this interleukin 6, helps to reduce inflammation in the entire body, but definitely in those areas, and that helps to reduce all kinds of chronic diseases like heart disease, type 2 diabetes, even certain cancers. And so what happens what you'll notice is a lot of the muscle glycogen sorry about that. So what you'll notice is a lot of our hormones are there to kind of help with fuel utilization in multiple different ways. And so part of that is with muscle glycogen utilization. And so our hormones are helping with things like glycogenolysis, which is where we take glycogen and break it apart so that it can be utilized as fuel. And so high intensity exercise results in a more rapid glycogen depletion of utilizing that for fuel, because at a higher intensity, you're relying on those anaerobic systems, and you need more of that glucose because your fatty acids, your Krebs cycle, your electron transport chain can't function and keep up with the energy demand. And so plasma epinephrine, so that release of epinephrine or adrenaline that happens when we exercise, especially at a high intensity, is a powerful stimulus for that glycogenolysis. And so the higher in the intensity, the more likely we are to see glycogenolysis to happen and then glycogen depletion to occur. And so that can kind of be seen by this graph. So the pink numbers show a percentage of VO2 max. Time is down at the bottom, and then glycogen depletion. So what percentage of glycogen did you deplete? So 0 would be you had full glycogen stores. And what you can see is the higher the intensity, you see that the exercise didn't go as long because your body couldn't keep up, especially for 120% over VO2 max. We can't do that for very long. And even 90% of VO2 max, that person pushed really hard for 30 minutes. And then 75, they got to 90 minutes. But what you see is this rapid, look at how the lines go, this rapid depletion of glycogen with the higher intensity exercise, and lower intensities don't pull from it as much because you're able to utilize those oxidative systems, those aerobic systems. And so you can see this correlates well with our epinephrine levels over time as well. So epinephrine, depending on the intensity, can do things a lot longer, but also the epinephrine doesn't climb as high, so they're very tied together. And so there's a lot of control that goes into muscle glycogen utilization. Remember, we talked about how important glucose was, and that fats can't burn without that being present, and the burning of glycogen or glucose without glycolysis occurring. And so we want to maintain that so we can keep going, but also it's a crucial in other areas such as the brain. And so there's a lot of redundant control of things that help to break down glycogen, and so that you don't have too much and you're not utilizing it too quickly. And so these are things like epinephrine with cyclic AMP and calcium and something called Calmodulin. And so this Calmodulin, calcium, we haven't really talked about too much. We've talked about it a little bit. And so this is when you release calcium from your muscle cells for contraction, this actually signals this Calmodulin response. And basically that kind of is linked to this glycogenolysis, this breakdown of glycogen. And that's shown through different kinds of studies we could talk about, but basically it's a local breakdown because if you give someone a beta blocker, which basically keeps their heart rate from going too high, we can actually use a beta blocker to keep someone's heart rate to never get above like 100, 120. If you give someone that and you have them exercise, we still see this glycogen utilization occur, and that's because we have this this Calmodulin effect, because epinephrine's not making it there in high concentrations like it was because the heart's not delivering as much blood, but we still see this similar pattern occur because of these local effects that we see. And so this kind of breaks down the control of glycogenolysis. So one of the most important things, as I've already mentioned, is this blood glucose homeostasis or steady state during exercise. Super, super important. And so there's a lot of things that go into making sure that stays there. But it's a very redundant system. So if one thing is kind of depleted, the other one kind of makes sure that we don't run out of glucose or shuts the body down before we run out of glucose. And so we mobilize glucose from liver glycogen stores. We mobilize free fatty acids, so we use those instead of glucose. We have gluconeogenesis, which is where we're taking lactic acid and glycerols and amino acids and other things to make glucose in a very big time of need. And we also block entry of glucose into the cells. So we're forcing that fatty acid use. Which this may seem counterintuitive, that realize when you start exercising, even your muscles, there is a blockage of glucose from entering the cells. And you may say, well, isn't glucose important to get into our cells if we're going to use fatty acids? And it is. And so there are mechanisms that happen when you contract your muscles. There's this blockage that occurs from glucose going into the cell, released from glucagon. But inside your muscles, you have these things called GLUT4 receptors. And a GLUT4 receptor is on the cell membrane, and when you exercise, they actually pop out. They're hidden when you're not exercising, when you're not moving those muscles, but they pop out when you exercise and using continuously. And a GLUT4 receptor, what it does is it captures glucose molecules to bring them into the cell. It's basically, think about like an airplane. If it goes under turbulence and you lose air pressure, you lose oxygen out of the cell, and the people who are alert need the oxygen first, and so you're always taught to put your mask on first, and that's what the muscles are doing. They're saying, hey, we're the ones needing the glucose, and so we need the glucose, so we're going to raise our hand, we're going to reach up for that mask and try to grab it, where all the other cells that may not need that oxygen at the moment are not doing so. And so that GLUT4 receptor is very important. And so this process is controlled by hormones, which are slow acting as well. So some of those, but also our fast acting ones like epinephrine, insulin, and glucagon. Those activate very quickly, but long term we also learn to have cortisone and growth hormone. So if this is an extended exercise, those can take place, or training effects as well. Again, we've talked about the thyroid acting in a permissive manner, so allowing other hormones to exert more of a full effect, so T3 and T4. There's, again, no real change in those. We talked about that last time, how they can take months to change. Cortisol is slow acting, and so you see peaks of them in the AM because of sleeping is a time to kind of break things down and get rid of waste products and build things up. And then they drop throughout the day. And so they're definitely helpful, and you can see the effects of what cortisol has. And exercise increases proportionally to the exercise intensity. So the higher intensity, the more levels of cortisol you'll see, because wanting to break those fatty acids down or glycerols down to make more glucose. So cortisol is good short term and for small things, but not good long term, like for extended periods of stress. And so you can see kind of how cortisol is connected to this blood glucose conservation, if you want to call it that, and see the graphs of how that may change as well. So then you get into growth hormone. Growth hormone is very, very slow acting. It takes a very long time. Yes, kids do grow quickly, but it's still over the course of weeks or months. It is quickest during that point because you have the highest levels, but it's definitely slow acting. It supports that role of cortisol of breaking things down and trying to save glucose and mobilize free fatty acids. There is an increase of growth hormone when you exercise, and it is actually greater in people like trained runners and trained people like that. And growth hormone can be used as a performance-enhancing drug. Doesn't quite have the same effects that you may see from steroids, but people think it does, but it actually has some really nasty side effects. And again, you can kind of see the chart and start piecing together what is happening with growth hormone and how it's having that positive effect being released during exercise and the changes that occur. Epinephrine, we've talked about being super fast acting. It mobilizes glycogen. It increases liver glucose mobilization, so getting sugar out of the liver, mobilization of fatty acids, and again, it blocks that glucose uptake. So they also do things like helping to increase your heart rate, blood pressure, which help you to get more nutrients and waste products away from your heart and deliver oxygen or into your muscles and away from your muscles, delivering more oxygen there and getting CO2 out. And so that's really good. And so what's really crazy, though, is epinephrine and norepinephrine in someone who's trained at a low-level submaximal exercise, we actually see after training that you don't release as much epinephrine and norepinephrine because your body is able to create these responses and increases in heart rate on their own and be able to deliver more oxygen on their own because of the adaptations we see from that. And if you go past maximal exercise, so if we're doing that 120%, so we know that you can only do this certain amount of exercise, that's your VO2 max, but we set the treadmill at a speed that's way past that. You can do it for a little while, and then you're going to tire out, but we see these massive increases in epi and norepi in trained individuals because their body is able to know when it needs it and give this huge release of these to help the body keep up. And so again, a chart that kind of summarizes that for you, and you can see with exercise what happens over time. Kind of scroll through those. You should be able to kind of interpret those, but if not, I'm happy to talk with you through those further. So insulin and glucagon are very fast-changing. Think about how quickly you're eating, you feel that sugar rush, and then it goes away as part of those. And so insulin typically isn't released during exercise, but we do see a decreased insulin response when you train. Your body is better able to pull that glucose out on its own. And insulin usually goes down during exercise because it basically is encouraging glucose uptake to store them for later usage. And during exercise, we don't want that to happen. Insulin tells every cell in the body to start pulling glucose in. And if that happened during exercise, we would quickly deplete the glucose in our bloodstream. And we have issues in the brain, and our muscles wouldn't be getting enough either. And glucagon basically does the exact opposite that insulin does. And so, again, kind of playing opposite roles. Glucagon released during exercise, insulin is released during mealtime, and vice versa as far as when they're kind of held back. And you can see those kind of changes over time with training in regards to those. And so epinephrine and norepinephrine also have a effect on the release of these hormones as well. Let's see. So our free fatty acids, there are hormones that kind of affect how quickly they can be broken down. So there are things that help them to mobilize quicker, which we've kind of noted here. And there's a lot of reasons that these may occur. Again, going to what's going on in the body, that they're signaling that. Not too worried about that. And that kind of finishes up our lecture on hormones during exercise. So kind of look those over, go with your book. But if you have questions, please shoot me an email. You guys have a great day, and we'll talk to you guys with the next lecture.